Logarithms. Our work with exponentials so far has been pretty straightforward because I just needed to always make the same base. But what happens when you can't make the same base? That's when logarithms come into play. And it can look a little startling, but the key is to remember logarithms are just asking a question. So when I see the log base b of something, that's asking me what power of b, right? So we're saying b to the x will give me a. Literally. That's all we're doing. Logs and exponents are inverse operations. They undo each other. Just like if I had 3x and I need to undo that, I divide by 3, x plus 3, we subtract 3. Now, when I've got something raised to an exponent and I don't know how to deal with it, I take the log of it to undo the exponent. Okay? So we need to get really good at converting back and forth. So if I am given, we're rewriting in logarithmic form. So if I am given 4 to the x power equals 72, okay? What power of b? So I rewrite that as log base 4 of 72 is the power. Okay? 3 to the x equals 9. Okay? Well, I know that x is 2. So let's see what that looks like as a logarithm. So I'm going to write log base 3 of 9 equals x. So what power of 3 gives me 9? 2 does. Okay. What power of 4 gives me 72? I don't know. That would require some calculation, and it's going to be a decimal. But this one I can see and I can work out pretty easily. Okay. So the same thing works in the other direction. If I ask for log base 2 of 17, and I want to know what that is, the alternative, I could rearrange it and say 2 to what power equals 17. Log base 4 of 64 equals x. Again, I know 4 to the third power is 64. 4 to the x equals 64. Okay? And the same thing is true even if I don't have numbers. I could start with log base q of x plus 3 equals w. And I can rewrite that as q to the w power equals x plus 3. I can leave it in parentheses or not. This rearranging pattern, we're going to practice a lot of that because it's going to make solving much easier later on. Okay? Speaking of solving, right? Our goal, just like before, okay, when we were writing the exponential equations and when we were solving the exponential stuff, is I need to isolate the exponential term. Okay, I need to do whatever it takes to get the exponential part by itself. Okay? And then, if I need to, I can use logs to solve. And we're going to do that by rearranging. Okay? So, let's look at this first example. Here's my exponential piece. I need to isolate that. So I'm going to do that by dividing by -7. So now 2 to the x equals, well, -72 divided by -7. 10 point, and again, we want to carry around as many decimals as we can, so let's keep 4 of them, 2857. 857. not an easy way to get that exponent figured out, so we're going to write it as a log. Log base 2 of 10.2857 equals x. There's our rearranging step that we just did. And then when I come to my calculator, okay, when I press math and I scroll down, so like there's my nth root, right, where we could change that one out, and this arrow means there's more down here. So if we keep looking, option A right there, it says log base, okay, which is what we've been saying, log base cube, right, log base 2. So when I pick that log base option, I'll write that down, math, and I'm going to go all the way down to A. I can type whatever I want. Log base 2 of 10.2857. It comes with the parentheses. We don't have to mess with anything. Hit enter. Keep 4 decimal places. So I can say that x is approximately 3.362, and I'm going to go ahead and round that 5 up to a 6. Okay. Plug that all the way back in to check it. -7 times 2 to the 3.3626. -7 times 2 to the 3.3626. 72.001. Pretty close to 72. It's an approximate answer, so our result when we go to check it is going to approximate where we were heading. One more. Here's our exponential term. Just like this, if this said 5x minus 9 equals 75, I would add 9, right? That would not be a problem. So it's the same thing. We're going to add 9 plus 9. So now 5 times 5 to the 4x equals 75 plus 9 is 84. Divide the 5 off. Divided by 5. And 5 to the 4x equals 84 divided by 5. 16.8. Okay, we're going to take the log and rearrange. Log base 5 of 16.8 equals 4x. So again, math. If you don't want to arrow all the way down, you can just go up and it does the same thing. It's still option A. 5 of 16.8, 1.7530. So we're just going to keep 1.753. 1.753 equals 4 to the x. Divide by 4. So x equals 4. 0.48383, approximately 0.4383. Now if I wanted to keep this exact terms, right, if I don't want to carry that around and get a decimal and then divide and get another decimal, I can deviate at this point. And when I divide, I'm just going to use log base 5 of 16.8 divided by 4. I can put all of that in there at once, and that's going to give me my x value. So if we ever need an exact value, that's where we're going to go. But this is more the direction we're heading. I need a reasonable approximation. So if we substitute that back in, okay, so 5 times 5 to the 4 times 0.4383 minus 9, does that equal 75? 5 times 5 raised 4 times 0.4383 minus 9. Again, we used an approximate value, so our answer should be approximately the same. And it is, 75.02, pretty close to 75. So we're good.